Okay gang, let's try this then. You've seen all those buildings in New York. Well, again, trig can help us actually find the height of these things. One of the uses I'll show you in a minute. Anyway, let's get to the basics. First and foremost, you recognise a trig question if there's a right angle triangle and there's an angle somewhere, either a number or sometimes it's a letter. Okay, if it hasn't got an angle mentioned or drawn on the diagram, then it's not trig, it's Pythagoras. That's a different story, we'll look at that again. Okay, so right angle triangles needs an angle in it, either a letter or whatever. Okay, so here we go. We can now look at what I've said here. That's the process, simple rules. For 90-degree angle, it's SOHCAHTOA. If there's no angle, Pythagoras. So here we've got some examples, okay? And what have I got here? Okay, so which of these four is Pythagoras? Is this one trigonometry? Yes, it is, because there's an angle. Okay, sides, yes, right angle, but it's an angle one. What about this one? Have a quick look. Again, yes, there's an angle in it, so this would be SOHCAHTOA. How about this one? Right angle, no angle this time, so this one is not SOHCAHTOA, that's Pythagoras. Look at that again. This one, is this one SOHCAHTOA? Yes it is, there's an angle with two sides given to us. So let's see how we would solve a couple of these. Here it is, because we move in the pen around, so here we go. So what we got? We've got basically two sides and an angle this time. And the way we solve this is as follows. First of all, with any SOHCAHTOA one, you basically label up. You label up, first of all, opposite the right angle is the hypotenuse. Always opposite the right angle. So here in this one, there's opposite, there's the H there. In this one here, there's the H there. In this one over here, there's the H there. Okay, and in this one here, there's the H there. Once you've labelled the hypotenuse, then you go for the opposite. The opposite is the opposite to the angle. There's the angle, so that one is the opposite. Okay, if I was doing this one up here, then there's the opposite, that one there. If I've got this one here, then here's the angle, so there's the opposite there. One more here, that one, there's the angle, a letter I know, but it doesn't matter, same thing, so there's the opposite. Once you've got that, back to the original again, then the other one is what's called the adjacent side, the A. So we've now labelled up the figure. Okay, once you've labelled up the figure, you now write down what you've got in terms of numbers and letters. Here I've got the 7 and the 10. 7 and the 10, and you see that that's O over the A. O over the A, you now refer to your SOHCAHTOA, and remember your SOHCAHTOA is SOH, where's it gone, there we are, SOHCAHTOA. So which of those is it? O and A, it's that one, TOA. And so down here, this becomes tan, in this case, of X. Now here's the awkward bit for you. Okay, to opposite that, it's an equation, so to opposite that, what do? I do x equals this tan minus 1, fun and games. Tan minus 1 and tan minus 1 over, in this case, 7 over 10. We've now nearly finished, and all we've got to do now is find out what tan minus 1, 7 over 10 is by scientific calculator. Okay, and we do that as follows. So here we have it then. Now, sin of sins, I'm using my iPhone because I haven't got a scientific calculator. You must have your own calculator. If you haven't got one this holiday, go and buy one and use it, get used to it. Anyway, the purposes of this, here we go. So first of all, I now have to work out what this 7 over 10 is. Now I actually know what that is, but having said that, I will still show it on the calculator. So I show this, tan minus 1. What is 7 over 10? I would divide 7 divided by 10, whatever the numbers were, equals, and I get 0.7. I could have told you that, but sometimes that number comes out to be a big decimal, 0.7. And now, with that on the calculator, I now want sine minus 1. There's my sine button. Sorry it's out of focus. But on your ordinary calculator, remember what you do is you press the shift function, which is second on here. That turns the button into sine minus 1. Then, in this case, I need 10 minus 1, I'm sorry, 10 minus 1, which is that one there. And what appears is the angle, 40.93, dot, 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 which, as usual, I round up to whatever they tell me. And in this case, I'm going to round that up to 40.9. Underline, remember, wherever you stop to one place, look at the second one, and if it's more than 5 it goes up, if it's under 5 it stays the same, 40.9 degrees to 1 dp. Again, I can't stress enough, every time you write an answer, write down exactly what you're doing. Okay, it's degrees, and in this case to 1 decimal place, if that's what they've told you to do. Okay, let's look at the second one. Second one here, okay, has got this going on. So here I go. Where's the hypotenuse? There it is, opposite the right angle. Where's the opposite? Opposite the angle. There it is. So that means that one must be the A. So this time round, I put the X over the 15, the numbers I've got, the sides. That's O and H. O and H, X and 15. And now O and H from my SOHCAHTOA is, SOHCAHTOA, it's so that's sine, S-I-N, of 32 in this case. Now this one's far easier because all that happens now, here's an equation. What's the 15 doing? The 15 is dividing, so I do the opposite. So I times by 15, so X equals 15 sine 32, or times if you like. And 15 sine 32 back. Okay, so on an ordinary calculator you would now simply type 15 times sine 32. On the iPhone you have to do it the other way around, you do 32, if I can get 32 out of it, which I can't, 32, oh I don't believe this, 32, 32, press the sin button, times it by 15, and the answer comes out 7.948, so 7.948, show the dots, and again this one you normally would do to 2 decimal places, so that'll be 7.95 when you round it to 2 decimal places. If it's centimetres, then write centimetres down to complete the sum. So there we have that. Okay, now on from there are problems which carry on with SOHCAHTOA in this way. I don't know whether some of you would like to know, but another way of writing down SOHCAHTOA is in these triangles. So, like that, ka, like that, and toa, like that. And now, look, they actually are the right way up. O and H, A over H, O over A. So you can see which is which. SOHCAHTOA. Might help, I don't know, for those of you. Now, back to my pictures. Okay. You remember, you've seen a picture of the Times Square ball, the New Year ball, which drops every New Year's Eve. Okay, well here's a diagram of that, beautifully drawn by Mr. T himself. And what I've done is, I've said that when I was standing 200 meters away from the bottom of the building, okay, looking at my eye, I measured the angle to the top of the building using a protractor or a device, was 35 degrees. Now this angle is what's known as the angle of elevation. The angle of elevation is from the horizontal up the line to the top of the building. So that's the angle of elevation. And so you've now got a triangle, look, you see, which you can now solve in the usual way. Okay, here's another case. This time a beautiful building drawing of the Empire State, which is 443 meters high, and if I was standing 400 meters from it, my question is, what's the angle of elevation? And again, you can see this is really a trig question hidden amongst the problem solving bits. So we can do it that way we've just been solving the other problems. Okay, so there's our questions. How do we go about them? Well, same old way as ever. So here we go. There's the right angle down there, so there's the hypotenuse. There's the angle, so there's the opposite, and the other one must be there for the adjacent. I now put the h over the 200, and I see that that is the opposite over the adjacent, which is what? Opposite over adjacent, it's TOA, so it's tan of which angle? 35 degrees. So what do we got here? We've got an equation. The 200 is dividing, so h is 200 times tan 35. Okay, back to calculator. You'll do it, remember, a different way to me here because of the calculator. So I will do 35 first here. 35 under the tan. I'll then times it by 200, and I get 140.04. 140.04. Check on your own calculator to see that you get that. Okay, round it off, and so that will be 140.04. Okay, let's try the Empire State question. Okay, so this time there's the right angle, there's the opposite. No, it's not. There's the hypotenuse. Naughty me. There's the hypotenuse opposite the right angle. There's the opposite. So the Empire State height is the opposite here, and this one therefore must be the adjacent. What have I got this time? I've got 443 over 400. 443 over 400 equals what? O over A. O over A. What's over A? It's tan again, but x this time. And remember, this is like the first one we did. The reverse of this is tan minus 1, the 443 over 400. I now have to do that by buttons. So here I go. Clear that. Whether it's gone clearing that. So I've got 443. I haven't got 7443. 443 divided by 400 is that. Always write down what that answer is. That's still 10 minus 1 because I haven't pressed the 10 button yet. 1.1075. Leave it on the calculator and now press the second function there. So I know 10 minus 1, that value, and there it is, look, 47.92. 47.92, so it would equal 47.9 underline to 1 dp. Okay, here endeth the trigonometry lesson. Hope it helps.